All right, physics kiddos, here is your requested video on what we're doing and what is going to be happening. So we'll start here in Classroom. Just a couple things to double check real quick on Classroom. There is a check-in form here on this, and it's past the pre-check-in, check-in form, and the first video. So it's right here on the check-in form. You click that, Mr. Boyd's eLearning check-in form. You can use that whenever you need to send me information or just want to check in and let me know something. That would be great. Miss you guys, and I want to make sure that you are doing okay. And then when we keep moving up, we have the e-learning plan and the copy of the textbook. So if we look at the e-learning plan, so this is just kind of got the way we're going to do this. Everything's due on Sunday at 11:59 p.m. Highlights of this, basically before 9 o'clock at night, I'll probably find a way to answer your question. Start about 8 in the morning. And then, again, assignments aren't due until the 29th, 11 p.m. Make sure you're doing what you need to, ask questions, stuff like that. Also, make sure that you are spending time with those that you're quarantined with, especially family members that are super important to you in this endeavor. So, and then we have an electronic copy of the textbook that is here as well. Okay, and then within here, the next thing is that you will actually see that the assignments are linked here as an actual assignment assigned to you. That way you can do that. I'm not going to click on that because it won't do anything but show your name. So I'm going to go to those assignments one at a time, and we're going to look at those real quick. So what you should see is that you should see the note boxes, okay, for kinetic energy, stored energy, gravitational potential, elastic potential, conservation of energy, and analyzing collisions. So when you look at these kind of things, you got the textbook there, but don't feel you have to be limited to the textbook. You can go to outside resources. That's perfectly fine. Okay, the next is the kinetic energy graded assignment. So just as you look at this, remember the units are joules. I'll go through these here in a little bit to kind of start going through some of the questions. When you look at the questions, when I go over them, the powers of 10 will be listed as E to the whatever the power is, because it didn't translate over to our program that we use on the TV very well. Okay, and I know that most of you are struggling with some of the later questions, and we'll talk about these. Okay, and then you have the potential energy graded assignment, same kind of thing. Show your work, number, unit. Units are joules, for this case meters, and kilograms are what we need to be in terms of those kind of things. All right, so then the next thing we're going to do is we are going to actually go into here and start looking at a couple things. So when we talk about kinetic energy is energy of motion. An object has to be moving. The main components of that are going to be the object's mass and its velocity. Okay. So with that, the equation that's essentially associated with this is that the kinetic energy, abbreviated KE, of an object is 1/2 its mass times its velocity squared. Okay, that mass being in kilograms, the velocity being in meters per second, kinetic energy in joules. So kinetic energy in joules, mass in kilograms, velocity in meters per second. Okay, so that's our base equation for kinetic energy when we look at trying to solve for that. Now, in a little bit, I'm going to go over how to derive that equation in terms of solving for velocity, which seems to be the one that is the biggest thing causing some trouble. So when we do that real quick here, I'm going to add another one. So if I have the KE equation, and I want to isolate it for V, or solve it for V. So the thing I'm going to do here is I'm going to divide by 1/2 m, or I can multiply both sides by 2 first, which is what I tend to do, which gets rid of your half, and then divide by the m. So 2ke over m is equal to v squared, square root both sides, and what you get is that V is equal to 2 times the kinetic energy in joules divided by the mass squared. You can put the half on the bottom. That's okay. It's completely up to you. But this is one of the derived equations that will help you along the way in here. There's also some equations for kinetic energy of an object that's spinning. We're really not going to do too many calculations with those. Okay. Stored energy. So when we look at this is just another form of energy. What we're mainly talking about there is things like gasoline, batteries, things like that, where there's going to be some sort of chemical reaction occurring that will release that energy. And we'll talk about some other types of that as well. Just another thing that's in there. Not a huge amount of calculations involved in that. Next one is gravitational potential energy. And with that, what we look at is we say that GPE, gravitational potential energy, or often just listed as potential energy, is mass times gravity times height. Okay? So again, with this, the mass is in kilograms, gravity in in meters per second squared, and height in meters, which will get us to our units of joules again. So with this, the G is RG on Earth of 9.81 meters per second squared. So it's about the height and the mass of the object. When you look at this, we talked before about the fact that this is pretty much the exact same thing as work. Okay, work is equal to force times displacement, and force can be mass times gravity for an object times displacement, which could all be the height. So that means that the amount of work we put in an object, if we lift it off the floor, or off the ground, and put it up on a shelf or up in the air, the amount of work that we had to do, measured in joules, is equivalent to the gravitational potential energy, object energy of position, how far it is above the Earth's surface. Okay? And again, we'll come back to this in a little bit. Elastic potential energy, this is stuff for springs and also rubber bands, stuff like that. This is going to be really important when we get back and we do the egg car, and being able to launch that car and also being able to stop that car. So again, rubber bands, springs, stuff like that. We'll come back to that with more. Okay, and the last little bit of notes just to highlight real quick. Conservation of energy. Energy that you have can only change form. It can't be created or destroyed. We can change form. So with this, if you put work into something, okay, that's equivalent and equal to the amount of potential energy the object has. Well, if that object is sitting up somewhere, being held above the surface of the Earth and falls, what we really look at is all of its potential energy up here is converted to kinetic energy by the time it gets to the ground. Because when we look at this, okay, the potential energy, mass, gravity, and height, okay, and then kinetic energy, 1/2 mv squared. Well, up here, the kinetic energy value of the object up in the air is 0 because it has no velocity. The potential energy value down at the bottom is 0 because the object has no height, okay? But it's not 0 in that it went away, it's 0 in that it changed form to the other one. So up here at the maximum height is the maximum amount of potential energy you will have. Down here will be the maximum amount of kinetic energy because it will move to what we again call terminal velocity. It will move as fast as it can to get to the bottom. And this will be important when we get to questions later about the flagpole and stuff like that. We'll do some demonstrations later in the week, and you'll do some demonstrations up there. But if we were to do something, when we talk about the numbers, if I say that the object has 100 joules of potential energy at the top, it's going to have 100 joules of potential energy at the bottom. Up here, it has 0 joules of kinetic energy, and down here it has 0 joules of potential energy. And again, that's because of the change in height and the increase in velocity. If we pick a point that would be halfway, our potential energy and kinetic energy would be 50-50 in these numbers, 50 joules, 50 joules. It will have lost half of its height, and it will have gained half the velocity it would get by the time it reaches the bottom. Okay? All right, so let's look at some of the questions with the graded assignment. This is primarily going to be, I'm just going to go over some helpful hints to you real quick, and we'll come back in a later video to go through them one at a time. So with this first question, again, as we just look at these sort of questions, keep in mind with this, the key part here is I'm going to change colors to highlight in red the important parts. This is in kilometers per hour. You're going to have to convert that. And again, when you look at this E means that it's to the 10 to the 4th power when you look at that. Don't forget to square the velocity. Okay. When we look at the next question, okay, as we look at that, there won't be anything that you're going to need to convert, but you're going to have to solve for the V, that equation we talked about before. Okay. With question number, 3 on your equations, again, no need to be able to convert anything, but you are going to have to manipulate that equation to solve for M to be able to get that, which will be very similar. Okay. Question number 4, this is something where we're going to start to look at the fact that the potential energy and the kinetic energy amounts, top and bottom, what I talked about before, can be equal to each other because you have a mass and you have the distance it was raised, okay, and it's going to drop to the bottom and you're solving for V, okay? All right, question number 5 on the kinetic energy assignment is about change in kinetic energy, okay? And again, when we look at this, pay attention to the fact that I've done a lot of mean things in here. Got to get them in meters and kilograms, okay? And then when we look at it, there's some conversion factors in there. So this has got a lot going on in one question, but I assure you once you get the conversions done, it's a straight plug-in kind of question, okay? Next question we look at here with Kayla, we have her weight, which is a force of gravity, mass times gravity. We want to know kinetic energy. She swims at a constant speed. Okay, it's 2 minutes and 22 seconds. It's all got to be in seconds before you'll be able to use that. Okay, so you got some conversions to do. The comment question, same kind of thing. When you look at this, you've got kilometers per second. You got to be in meters per second. Okay. And then the truck question, you're in kilograms, you're in meters per second. Again, this is just going to be that the two kinetic energies will be equal to each other, and you solve for the unknown velocity, which is the velocity of the truck. So you set the two KEs equal to each other. All right. On the potential energy graded assignment questions, just a couple things to look at those. Again, when you look at this first question, you've got the man and the platform. That'll be key. The units don't have to be converted or changed to anything. This question's fairly straightforward, okay, so don't make it too complicated. Question number 3, again, the hint there that KE equals PE, you're going to have to do some manipulation. Set the two equations equal to each other, 1/2 mv squared equals mgh, and solve for the h. The pickup question, this is one where you've got, there's no degree symbol on this. Sorry, the degree symbol is lost. This is a degrees. So again, what you've got there is you're going to have a situation where you're going to have to do your sketch. Okay. And again, you know the height. We did this before. If it's 825 meters here, this is your known angle of 22 degrees. And again, then you know the height. Okay. All right. And then we have parts A, B, and C on this. We're going to do this as a demonstration. Just again, think back, if you would, when you're looking at this question for parts A, B, and C, go back to this part and think about what I was talking about here. I'll just give you a quick sketch to help you, because I think this video has gone a little bit longer than I wanted to. But again, if we've got a flagpole, okay, and we are going to calculate the gravitation when it passes the top of the flagpole, so it's going to go past it, okay, we want to know the height that's going to be there when it gets past, as it passes this point. And again, you'll look at those kind of things. In part B, when you're looking at the kinetic energy as it passes it, keep in mind there's a conversion thing. If you're going up, think about the fact that the amount of it's slowing down, so it's gaining kinetic energy, or I'm sorry, losing kinetic energy as it gains height. And then when it starts to fall back down, it will gain velocity and we'll lose height. So KE and PE and the move back and forth. Again, with this, you're thinking about this kind of thing that we've looked at before, where the velocity up here is 0, okay? So think about those kind of things as we move up. Again, we'll go over this with more detail later. Hopefully all that helped. If it didn't, or you need further help, please again make sure you fill out that form so I know. I'm not keeping true meeting hours for us unless we get a large number, just to avoid it for all of the other classes. So if you need specific help, let me know. There might be a group of you that wants to meet at the same time. Otherwise, we'll try some Google Hangouts, maybe some Zooms, and email back and forth. And again, I will post the answer key to this so you can look at it at some point. And then I will start working through these problems with you in our next video tomorrow. So relax, take it easy, do a little bit at a time. Don't spend hours on this in one day. Spend a little bit, get your notes done, work through a problem or two, and we'll catch up. And if I don't hear from you, I'll see you guys, or not see you, I'm not visible in this video. I will have a video that'll be visible later with my hat on. So for those of you that listening to this here in physics, have a great day, kiddos. Miss you very much. We will talk.